Welcome guys. In this video we will discuss about memory layout of a program in C and C++. Memory layout of a program refers to the organization of memory to various components of a program. When we run our program, operating system assigns a block of memory to our process. The memory blocks contains the different segments. In this video we will discuss all about these segments. So let's get started. When a C++ program is executed, the memory block of the running process contains following segments. First one is the text segment. The text segment is also known as the code segment. It stores the complete code in the form of instructions. When we compile our code, it generates a machine level instructions of the program functions and methods. These instructions are stored in the code segment of the memory. It is a read-only area. Therefore, program cannot modify the code segment at the runtime. Now, after that comes the data segment. This data segment is divided into two parts. First is uninitialized data segment and second is initialized data segment. This data segment contains the global variables and the static variables. When we declare global variable or a static variable and initialize it at the same time, like here, then it will be stored in the initialized data segment. Whereas when we declare global variable which are not initialized, then in that case it will go to the uninitialized data segment. Before the start of a program, kernel sets the 0 in all the uninitialized data segment. Therefore, when we declare global variables or static variables and don't initialize them, then by default their value will be 0, because before the start of the program, kernel will set 0 in this uninitialized data segment. Whereas the initialized data segment contains the initialized global variables and the static variables. After that comes the heap segment. The heap segment is used for dynamic memory allocation during the runtime. For dynamic memory allocation, C and C++ provides various functions like new, malloc, calloc, and to delete the memory, free and delete. So all these functions allocates the memory from the heap. Program can allocate and deallocate memory at runtime. And an inefficient memory management of heap can lead to problems like fragmentation or memory leaks. We will discuss that in detail in the upcoming videos. Now the next segment is the stack. The stack segment contains function call information like what arguments we have passed in the function, the local variables, and the variables returned by the functions. The stack segment is helpful in controlling the execution flow of the program. Whenever we call a function like this, a new stack frame get created, and inside this stack frame the arguments and the local variables will be allocated in a last in and first out order. Let's look how the stack will be occupied in this program. So first of all, main function will be called when the program starts. First value in the stack will be argc. After that it is argv, and then we create a local variable. So the local variable will be in the stack. This is the stack. After that this pointer heap variable, and after that we call the function. Now when the function is called, a new stack frame will be created here, and inside this stack frame first the arguments will be stored like a, b, and the sum variable like this. So when the function returns, stack unwinding happens. So first of all sum will be deleted from the stack, then b, and then a. So control will come back to this position in the stack, and the when main function ends, first of all heap variable will be deleted from the stack, then local variable, this one, and then the arguments. So stack is also called last in and first out. It means the element which was added in the last will be get deleted first. Now next segment is command line arguments. When we run our program like this script and we provide certain arguments, these arguments are called command line arguments and will be stored in this section. And the next section is environment segment. Environment segment contains the environment variables. This is for your operating system to pass the information and configuration data to the program. So these environment variables will be stored in this segment. Now let's relook. When a program starts, operating systems assigns a block of memory to the process. So this block of memory is divided into different segments. First one is the text and the code segment. It contains the complete code in the form of instructions, and it is a read-only segment. You cannot change the data at the runtime. Second is the data segment, which contains the uninitialized and initialized. Uninitialized variables will be global and static variables which are not initialized, whereas initialized variable contain the global and static variable which are initialized by the programmer. Now this uninitialized data will be set to 0 by kernel. Therefore, all the global variables which are not initialized or static variables which are uninitialized are always set to 0. After that comes the heap. For the dynamic memory allocation, we can use the different functions like new and malloc to allocate the memory from the heap and delete it. After that comes the stack, which contains the local variables and the function arguments. After that, we have a segment for command line arguments and environment variables. So it is essential for a C and C++ programmer to understand the memory layout of a program. It will help in optimization and debugging. Awareness of this memory model is especially beneficial when working with embedded systems, operating system, and applications that require precise control over system resources. So that's all for this video now. This video is a part of Pointer's course in C and C++. For more videos related to this course, you can check out our playlist on YouTube, or you can go to our website thispointer.com for the complete course. Thanks for watching. Don't forget to like the video and subscribe to our channel.